Hello friends, welcome back. Hearty welcome to you. In this session, let us see how to find out whether a given natural number is a prime number or not. If a natural number n has no prime factors or divisors less than or equal to square root of n, then n is a prime number. If a natural number n has no prime factors less than or equal to square root of n, then n is a prime number. Now let us take one example and see how we can use this logic to find out whether a given number is a prime number or not. Now let's consider 313. Now 313 lies between which two squares? We know that 313 is between 17 square and 18 square. 17 square is 289 and 18 square is 324. Now we have to consider all the prime numbers up to square root of 313. That is, we have to consider all the prime numbers up to 17. Now what are the prime numbers up to 17? We have 2, 3, 5, 7, 11, 13, then we have 17. Now we have to check whether 313 is divisible by any one of these numbers. Let us check them. 313 divided by 2, no. 3, no. 5, no. 7, no. 11, no. 13, no. 17, no. So 313 is a prime number. Let's go to the next example. Next, let us take 343. 343 comes between which two squares? 18 square and 19 square. We know that 18 square is 324 and 19 square is 361. That means I have to consider all the prime numbers up to 18. What are the prime numbers up to 18? Like what we did earlier, we have 2, 3, 5, 7, 11, 13 and 17. Now let us see whether 343 is divisible by any one of the given numbers. 2 no, 3 no, 5 no, but 7 yes. I can write down 343 as 7 into 49. That means 343 is not a prime number. It is a composite number. Let's go to the next number. Next number we will consider 391. We know that 391 comes between 19 square and 20 square. 19 square is 361 and 20 square is 400. So we have to consider all the prime numbers up to 19. So all the prime numbers up to 19 are 2, 3, 5, 7, 11, 13, 17 and 19. Now let us see whether given number 391 is divisible by any one of these prime numbers. 2, 3, 5, 7, 11, 13, 17, 19. 2 no, 3 no, 5 no, 7 no, 11 no, 13 no, 17 yes, because we can write down 391 as 17 into 23. So 391 is a composite number. Let's go to the next one. Next number we will consider is 427, and we know 427 comes between 20 square and 21 square. 20 square is 400 and 21 square is 441. So we have to consider all the prime numbers up to 20. So they are 2, 3, 5, 7, 11, 13, 17 and 19. Now we have to check whether 427 is divisible by any of these prime numbers. 2 no, 3 no, 5 no, 7 yes, because we can write 427 equal to 7 into 61. So 427 is a composite number. Now let us check for 569. We know 427 is not a prime number. We are checking now for 569. 569 is between squares of 23 square and 24 square. We know 23 square is 529 and 24 square is 576. So we have to consider all the prime numbers up to 23. So let's write them: 2, 3, 5, 7, 11, 13, 17, 19 up to 23. Now is 569 divisible by any one of the prime numbers? 2 no, 3 no, 5 no, 7 no, 11 no, 13 no, 17 no, 19 no, 23 no. So 569 is a prime number. Now let's take the last example. We have 853. Now 853 is between squares of 29 square and 30 square. We know that 29 square is 841 and 30 square is 900. So we have to consider all the prime numbers up to 29. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. We have to check any one of these prime numbers are factors of 853. So 853 divides it to no, 3 no, 5 no, 7 no, 11 no, 13 no, 17 no, 19 no, 23 no, 29 no. That means 853 is a prime number. Now let's try to solve some interesting examples related to prime numbers. The number 13 is a prime. If you reverse the digits, you also obtain a prime number 31. What is the larger of the pair of primes that satisfies this condition and has a sum of 110? The number 13 is prime. If you reverse the digits, you also obtain a prime number 31. What is the larger of the pair of primes that satisfy this condition and has a sum of 110? Now, what we know about the problems related to two digits? So we take the digits as x and y. The reverse number will be yx. The value of xy is 10x plus y, and the value of reversed number is 10y plus x. But given to us that the sum of both the prime numbers is equal to 110. If we simplify, we will get 11 into x plus y is equal to 110. That means we know x plus y equal to 10. So both the digits should add up to 10. Now what are the combinations we have where we can get sum of 10, and also both the numbers should be prime, both the numbers should be prime numbers? I can have 1 and 9. One combination I can take 1, 9. Then I can take 3 and 7. Then I can take 5 and 5. If I take 1 and 9, 9 is a prime number, but 91 is not a prime number, so ruled out. If I take 55, 55 is a composite number, so that is also ruled out. Left out is 3 and 7. 37 is a prime number. If you reverse it, 73, that is also prime number. So our answer is 73 because we have been asked the larger of the pair of primes. That means answer is 73. Let's solve one more interesting example.